this video is about matrix multiplication. The first thing that I want to mention, what we had before when we were discussing addition or subtraction, the two dimensions were supposed to be both the same. When we're doing, and then for scalar multiplication, the dimension didn't matter as long as you had a scalar multiplied by a matrix. Is this the same for matrix multiplication? No, matrix multiplication is entirely different from what we had before. And so let's say if I'm multiplying two matrices, A and B, and matrix 1 is M by N matrix, and the size is M by N, then matrix B and the number of the rows in matrix B has to be the same as number of columns in matrix A. So matrix B should start with, the dimension of matrix B should start with N. So in the M and K at the end can be different or can be the same. It doesn't matter as long as N, the number of columns of the first matrix, matches the number of rows of the second matrix. We're okay. And then the only thing that matters if M and K are different, then so if M not equal to K, then B times A is not defined. So the first thing that I want to do is to start with a smaller size example. Let's do an example. And then after I do a smaller size example, I want to do a bigger, two bigger size matrices multiplication. And then I'll tell you an example of why matrix multiplication makes sense and why we need them. And so let's start with a smaller size example. So matrix A is 2 by 2. Matrix B has to start with 2. And I put in, let's say, 2 and 5. How does matrix multiplication work? This is how. You multiply rows of the first matrix by columns of the second matrix, and then in the resulting matrix, the result of this multiplication goes into an entry. So in here, 3 multiplies by 2, 2 multiplies by 5, and they add together. So I will have 3 times 2 plus 2 times 5, and this would be the entry 1, 1. Then I have another, for this matrix, I have another row. It would be 1 and 3 multiplied by the only column that I have. That would be 1 times 2 plus 3 times 5. So 1 times 2 plus 3 times 5. So the first entry is 6 plus 10, which is 16. The second entry is 17. So and that's the resulting matrix. So in this specific case, let's say this is matrix A, this is matrix B. Matrix BA is not defined, first of all. Why? Because B is 2 by 1 and A is 2 by 2, and these two are not the same. And so when they're not the same, then the multiplication is not defined. Now, the other thing to notice is this: when I talk about multiplication of a row by a column, I go with the first entry of the row times the first entry of the column, second entry of the row times the second entry of column, and so on and so forth. This also, if you're familiar with dot product, this resembles the dot product, except that this is not how, if you've seen dot product before, this is not how you saw two vectors before. But also, this is the vector of the row, this is a vector of a column, and you're really multiplying dot producting the two vectors. So the next thing that I want to do is to give a larger example of matrix multiplication. This was a beginner example. Now we make it a little larger. So let's write another matrix. Let's try to multiply 3, 5, 2, 15, 2, 0, negative 2, 10, 1, 5, 4, 5, 5, 2, 7, 2, 6, 3, 7, 5. First of all, let's see if this is defined. The first matrix is 3 rows, 4 columns. So the first matrix is 3 by 4. Second matrix is 4 rows and 2 columns, and these two match. Therefore, this matrix multiplication is defined. And the next thing is to multiply the two matrices by each other. And so let's start. And I know that the resulting matrix will have 3 rows. Again, there's one little trick that we can use. 3 times 4, 4 times 2. These two are the same, and resulting is 3 times 2 matrix. So it would be 3 times 2. Now, let's try to multiply. As we discussed, we choose rows of the first matrix, multiply by columns of the second matrix. I start with row 1 first. Row 1. How many columns do I have? 2 choices. Start with the first choice. That would be the first entry times the first entry, plus the second entry times the second entry, plus the third entry times the third entry, plus the fourth entry times the fourth entry. Okay. That becomes row 1, column 1, entry of the resulting matrix. Now, how do I continue? Keep the row 1 until you're done with all the columns of the second matrix. So row 1 is kept. What is the other option for columns? This one. And multiply. 3 times 2, that's the first entry, times the first entry. 5 times 2. 2 times 3. 15 times 5. And I ran out of the columns in the second one. So I start with the second row and the second row of the resulting matrix as well. So this time around, second row and first column of the second matrix. Again, first times first, second times second, third times third, fourth times fourth. And now, that's the first entry of the second column. Keep the row again the same until you run out of the columns of the second matrix. And I go with that one. 2 times 2 plus 0 times 2 plus negative 2 times 3 plus 10 times 5. Now, I'm done with all the columns, so I associated the second row with all the columns of the second matrix. Last thing is the last row multiplied by all the columns. So this time around, I'm going last row, first column, and I write 1 times 5 plus 5 times 7 plus 4 times 3 plus 5 times 5. Now the second column, we're staying in the same row again. 1 times 2 plus 5 times 2 plus 4 times 3 plus 5 times 5. And that is the entire process of how we multiply. What is remaining is to put these in your calculator or however mean that you have. I put this one in and I get, for this one I get 167. For the second one I get 97. For this third one I got 68. Let's write it in the organized way. So I got 167 for that one, 97 for that one. For this, 68, for that, 48, for this, 99, and for this, 49. And so this concludes the example, the second example for matrix multiplication. Other questions is, can we switch the order for this matrix multiplication? No, we cannot, because the number of rows here is 3. The number of the number of rows is 3, and then the number of columns here is 2, and they don't match, so the order cannot change. And then the very last thing is I want to give you an example that explains, it was one of the application of matrix multiplication, one of the important applications of matrix multiplication. So it makes sense why we're doing what we're doing with matrix multiplication. So now we're done with the process of multiplying the two matrices. The next thing is just to finish it up by multiplying and adding all these values. So I use my calculator, and hopefully I'm right. And this entire thing is 167. This entire thing is 97. This entire thing is 68, 48, 99, and 49. So let's write them up in one matrix. 167, 97, 68, 48, 99, and 49. Last thing that I want to mention, so this was, if this is matrix A and this is matrix B, we define AB, and this is A times B. The question is BA defined? B was 4 by 2, A is 3 by 4, and the middle one, the middle two dimensions are not the same, therefore this is not defined. And the next thing that I want to do after erasing the board is to continue with an example that amplifies the importance of matrix multiplication. One of the important reasons that we need matrix multiplication and the complexity that comes with it is important to have with that example.